In this video, I'm gonna teach you about the geometric series and we're gonna study the test for divergence. The first thing that we're gonna study is gonna be about geometric sequence. The geometric sequence will be the sequence that you have the form A. The first term is A, and the next term or the consecutive term turn out to be multiple of A, so it's going to be AR. And the next term, the consecutive term of AR turned out to be just the multiple of AR, so it's going to be AR square. So you see that the criterion for being a geometric sequence will be you have A1, A2, A3, and AN here. So you see that A2 over A1 will be equal to A3 over A2 equal to A4 over A3 and so on. And this thing equal to the ratio R. The ratio R here is called common ratio. Okay, so it's going to be the sequence in the form when you have the consecutive term, the quotient or the ratio of the consecutive term turn out to be constant R. So it's going to give you in the form of A1 equal to A, A2 equal to AR, and AN equal to AR to the n minus 1. Okay, so that is going to be the thing that I conclude here. And it's going to be the common ratio. And you have the geometric series turn out to be the sum of the geometric sequence. So it's going to be, you'll have to find the sum A plus AR plus AR square up until AR to the n minus 1. To determine conversion or diversion for the geometric sum, we're gonna use the fact that you have Sn equal to A plus AR plus until AR to the n minus 1 that we use to prove this one by induction. Okay, so I used to prove this one already, that it's going to be 1 to the R to the N over 1 minus R. This one is induction that we studied last week. Okay, so it's induction. Or we can use the technique like you have Sn equal to A plus AR square up until AR to the n minus 1, and you multiply R to the whole equation. So you're gonna get minus Sn equal to AR, and then you would just sum these two guys up. Okay, so you would just sum these two guys up. So you would have, okay, so this one you multiply by minus R. I think I make a mistake here, so it's going to be just multiplied by R. Okay, and you subtract these two guys. Okay, so the minus sign should be in the middle. Okay, so you subtract these two guys. So you subtract these two guys, so the thing that you get is gonna be on the left side, it's gonna be Sn minus R minus Sn, and on the right side, you see that this guy will be getting rid of. Okay, so we can get rid of, and you see that you're gonna get only A and A to the R minus N. That is going to be survive in this case, and you see that this one will be the what is called the right side. Okay, so you have Sn equal to A 1 minus R to the n over 1 minus R when you have R not equal to 1. However, when R equal to 1, Sn turn out to be equal to Na, so it's going to be A plus An copies. And the series, you're gonna take limit of the green guy, okay, like we have in the previous video. So you're gonna just take limit and go to infinity of Sn. And you see that it's gonna turn out to become 0 or divergent depending on so this guy turned out to be 0 or divergent depending on the absolute value of R. If you have the absolute value of R smaller than 1, okay, so if you have the absolute value of R smaller than 1, it's gonna turn out to go to 0, and the series turned out to be equal to A over 1 minus R. And if it more than 1, okay, so if it fall into the second case, so if it fall into this case, it's gonna turn out to be divergent, okay? It's depend on that guy. So we're gonna have like a two formula. So when you have absolute R less than 1, it's gonna turn out to be conversion. And if it turn out to be less than 1, it's more than, sorry, if it's less than 1 is conversion, and it's gonna be equal to A over 1 minus R, and it's gonna turn out to be divergent R twice. Let me give you several examples here to gain some experience on geometric series. So you have series n equal to 1 to infinity of 1/3 to the n minus 1, okay? So you're gonna have this one, okay? And you have series n equal to 1 to infinity of pi to the n minus 1, series n equal to 1 to infinity of -1 to the n. The thing that we like to determine, so we like to determine conversion, divergent. Okay, so it's convergent, divergent. So for this one, the thing that we're going to consider turn out to be what is R. So for the first case, you would have R equal to 1/3. Okay, so R equal to 1/3 less than 1. So it's going to be conversion. The second case, you have R equal to pi is more than 1. So it's going to turn out to be divergent. And the third case, you have R equal to -1, and absolute value of R is greater than or equal to 1. Okay, so it's gonna turn out to be in the pink case as well. So it's gonna turn out to be divergent. Okay, so that is going to be how to test for conversion or diversion of the geometric series. Okay, so this guy is called geometric series. So we're gonna find the sum if the series converts. So you see that it's 7 minus 35 over 9 plus 175 over 81 minus 875 over 729. So the thing that we are trying is going to be, we try to compute, okay, the common ratio. So you have A1, A2, so it's A1 plus A2 plus A3 plus A4 and so on. So you have A2 over A1 equal to -35 over 9 over 7. So it's going to be -59. A3 over A2. So it's going to be 175 over 81 over -35 over 9. Okay. And you're gonna get rid of 81 and 9 and 35 and 175. So it's gonna also equal to 1 over 9. So you see, if you try this one, so you would get the common ratio R equal to 5/9. Okay, so you get R equal to 5/9. So this one will give you the common ratio, and you're gonna have your A equal to A1. Okay, so this one will be our A plus AR plus AR square and so on. So this one will become A over 1 minus R, okay? And you know also that absolute value of R equal to 9 smaller than 1, okay? So basically plug in. So it's going to be 7, okay? So you have A equal to 7, which is this term, okay? A equal to 7, and you have 1 minus R, so it's going to be over 1 minus 9, okay? And this guy will become 7 over 9 plus 5 over 9. So it's going to be 14. So it's going to be 9 over 2. Okay, so that will be our sum or our geometric sum. Let me move this one a little bit further. So that will give us for the final answer 9 over 2. The second one, okay, the second one we're gonna try to find this guy in the form of, okay, so this one is gonna be, you need the sequence in the form of series into 1 to infinity of a r to the n minus 1. So you need to have the series in this form. And you see that this guy is kind of a little bit different, but we're gonna try to like expand this one or try to sum this one a little bit. So you just simplify this one. So this one will be 4 to the n, 2 to the 2n times 2, negative 1 to the n, negative 1 over 5 to the n. So we just use the exponential rule in order to obtain something like this. And you see that this guy turned out to be 4 to the n times negative 2 minus 1 to the n over 5 to the n, okay? So it's not that hard to do. So it's going to be just series n equal to 0 to infinity. And you're gonna see that we can combine the yellow term, this term, this term, and this term together to get negative 2, and you get negative 4/5 to the n. Okay, so it's going to become here. And you see that this guy can be written as negative 2, okay, when n equal to 0. Okay, so n equal to 0, you have n equal to 1, so it's going to be negative 2. Negative 4/5, okay, and you have negative 2, negative 4/5 square, so on. So you have, okay, so you have A and you have R. So for this one, n equal to 0, n equal to 1 for this term, okay, n equal to 1, n equal to 2, okay. So for this one will be A plus AR plus AR square and so on, okay. So for this one, this series will be equal to A over 1 minus R. And R in this case equal to negative 4/5. And you have A equal to negative 2. Okay, so you have A equal to negative 2 and you have R equal to negative 4/5. Equal to negative 4/5. Let me, okay. So it's gonna be just a equal to -2, equal to -4/5. So it's gonna be -2, and it's gonna be 1, 1. So it's gonna be 5 plus 4 over 5. So it's gonna be -10, 9. Okay, so that is gonna be just the second question. Okay, so that is gonna be, you need some analysis on the term a little bit. For the next one, you see that you're gonna have to like separate the first two terms that not gonna be common with the third and the fourth. So you see that these two terms, you need to sum them separately because it's not gonna be in terms of 5, 4 like you have. So you're gonna have your A, this one will be AR square, okay, and you have 0.0000054 over 0.054. Okay, so this one, if you write this one, is gonna be 5, 1, 2, 3, 4, 5. So it is 5.4 10 to the -5. Okay, so that the significant number, and you have 5.4 and you have 10 to the -2. So this one become 10 to the -3. Similarly, with the next term, you have how many zero? I do have 1, 2, 3, 4, 5, 6, 7, 0, 0, 6, 7, 5, 4. So it's gonna be 5.4 10 to the -8 over 0.0000054. So this guy is 5.4 10 to the -5. So you have -3. So in this case, you're gonna have the common ratio R equal to 10 to the -3, okay? So you're gonna sum the whole thing. So the first two terms will be equal to 8.2, that you must sum them separately. Okay, so you just sum these two terms first. And then for the rest of the term, you're gonna use geometric sum. So for the green term, so for this guy, okay, it's gonna turn out to be A over 1 minus R. And your A in this case is 0.54. So it's gonna be 0.54. 0.054. Okay, and it's going to be over 1 minus R, so it's going to be 1 minus 10 to the -3. Okay, so it's going to be 10 to the -3. So for this guy, it's going to be 0.54, so it's going to be 5.4 to the -2. Okay, so it's going to be 5.4 to the -2 over, okay, so it's going to be over, this guy will be 1 minus what? 1 minus 1 over 1,000. Okay, so it's going to be 1 minus 1 over 1,000. So for this one, okay, so if you calculate this one correctly, so it's gonna turn out to be 999. Okay, so it's gonna be 999 on the bottom, right? So it's gonna be 0.54. I gonna have, okay, do this one in this way. So on top, I would get 54, 10 to the negative 3. On here, it's going to be 999, 10 to the negative 3 as well. Okay, so that helped a lot. So why did I use whole number instead of decimal? Because it's going to be easier to like cut the number down. So it's going to be 54 on top, and you have, if you confuse, let me explain this one a little bit. So for this whole thing, so for this one, it's gonna be 999 over 1000. Okay, so that term is quite clear. So it's gonna turn out to be this term, basically. Okay, so it's gonna turn out to be this term. And you see that this will allow you to get rid of 10 to the negative 3. So it's going to be 54 over 999, and you have, you can get rid of by canceling with 6. So it's going to be, you have 9, so it's going to be 6, and you get 9, so it's going to be 1, 1, 1. Okay, so it's going to be 1, 1, 1. So it's going to be 6 over 1, 1, 1, and you can divide by 3, so it's going to be 2 over 37. Okay, so this one is going to be 8.2, which is, so let me conclude that. So this one become 8.2 plus 2 over 37. Okay, so it's going to be 82 over 10 plus 2 over 37. And you just sum this one as fraction. So it's going to be 370. And you have 82 times 37 plus 20 for your final answer. So it's going to be written in terms of fraction. Okay, so I leave you on your own this one. Let's complete this one. So I just use calculator. It's not a big deal. So times 37, okay, and plus 20. So it's going to be 3754 over 370. Okay, that's it. Okay. The next thing that we're gonna study is gonna be about harmonic series. The harmonic series will be the series that is divergent. Okay, so that is divergent. The way that we're gonna show that it's gonna be divergent is gonna be, you gonna try to find Sn. So in this case, you have An. Okay, so in this case, you have An. Okay, so you have An equal to 1 over n. So you're gonna compute S1. So you have S1 equal to A1 equal to 1. Okay, so you have S1 equal to A1 equal to 1. Let me move this guy to the side here a little bit. And you're gonna compute S2. So S2 is gonna be A1 plus A2. So it's gonna be 1 plus 1 half. Okay. S3 is gonna be A1 plus A2 plus A3. So let me just sum them up. So it's gonna be 1 plus 1 half plus 1 third. And S4 is gonna be 1 plus 1 half plus 1 third plus 1 quarter. Okay, so that my S4. And if you continue, I'm gonna I'm gonna sum this one. Okay, so we like to find this 1 is 4, and if you sum, okay, you see that you have 1 plus 1, you have 1 plus 1 half, okay, and for the third one, okay, it cannot be simplified further. However, for this one, you see that this one is 1 plus 1 half. And if you sum these two guys, it's going to be a little bit trick here. So if you sum this, you see the pink one. So this one will be, if I have 1 plus 1 half plus 1 quarter plus 1 quarter. So you see the pink guy, okay, so you see the pink guy is 1/3 and 1/4. However, on the other side, you have 1/4 and 1/4. If you compare 1/3 and 1/4, you know that 1/3 is small, 1/3 is what is called 1/3 is uh, 0.33. Okay, so 1/3 is 0.33 and 1/4 is 0.25. So this guy turned out to be more than, okay, so turned out to be more than, so S4 is more than 1/4. Okay, so we can have this one. And why did we need 1/4 plus 1/4? Because if you have 1/4 plus 1/4, you allow to get 1/2, and 1/2 here is going to turn out to be 2/4. So it's going to be another 1/2. Okay, so that is going to be the term that you have. So if you see this pattern, you have S8, so it's going to be 1 plus 1/2 plus 1/3 plus 1/4, 1/5, 1/6, 1/7, 1/8. And you see that this is just the pink guy and this is just the blue guy. Okay, so you can combine the term like this one. So you combine the term here, it's going to be more than, okay? So we did the same thing as the previous case. So you have 1/3, so you're gonna write 1 plus 1/2 plus 1/4, 1/4. So this one is the pink parenthesis, okay? And you're gonna have the blue parenthesis, so it's gonna be plus 1/8, 1/8, 1/8, 1/8. So you see this pattern, and this guy is the orange term. Okay, so you see it's gonna turn out to change into the term that higher than 1/8. Okay, so you see, why did I do this? Because we'll be able to combine the term similarly. So you see that this guy turned out to be 2/4, so this guy is gonna turn out to be 1/2. This guy turned out to be 4/8 equal to 1/2 as well. So it's gonna turn out to be 1 plus 1/2 plus 1/2 and plus 1/2. What do we learn so far? We learned that this one is S2. You have 1/2, okay? And this one is S1, you have 1. And you have S4 and S8. If you look at this guy closely, it's going to be S of 2 square. This guy is going to be S of 2 to the third. And the index here turned out to be 2 and 3, and it turned out to be the number of the term that we also have here. So it's going to be 2 terms, and this guy is going to be 3 terms, and this guy turned out to be 1 term. Okay, and this one is nothing else, is 2 to the first, and No surprise, it is one term. Okay, so it's one term. So you must recognize something like this first. And so if I ask you to, can you guess? Okay, can you guess for s of 2 to the n? Okay, so if you have s of 2 to the n, it's going to be more than, okay, so it's going to be more than, I use the green color, more than. So here is going to be the index n, okay, so it's going to be the index n, and it's going to be 1 plus, okay, so it's going to be 1 plus 1 half, 1 half, 1 half, and how many terms do we have? So you see the index here, one term, two terms, three is three term. So if it's turned out to be n, so it's gonna be n term. Okay, and this one will become 1 plus n over 2. Okay, so this one will be 1 plus n over 2. Hence, we have shown that for n greater than or equal to 1, we have s2 to the n is more than 1 plus n over 2. So if you take limit n go to infinity of s2 to the n, this guy will be more than limit n go to infinity of 1 plus n over 2, and this guy become infinity. So what does it mean? It means that this guy, okay, so it means that limit n go to infinity of s to the n, which turned out to be equal to infinity. Okay, so we have this red limit here. Okay, so it's going to be this red limit is more than infinity. And when you have the limit is more than infinity, it's turned out to be equal to infinity. So it means that s infinity equal to infinity. So the series n equal to 1 to infinity must be divergent. N equal to 1 to infinity, 1 over n diverges. Okay, so that will be the solution for this harmonic series is divergent. It can be shown by finding Sn, and it's not going to be Sn in a closed form. It's going to be Sn more than the sequence that you know that it is divergent. This is another trick. Okay, so when you have the n is more than the sequence that gonna approach to infinity, it means that your sequence is also going to be infinity as well. So it means that your series turn out to be divergent. Okay, so that will be just an example for harmonic series. And for harmonic series, it's going to turn out to provide you the example that you have the limit of an equal to 0, but the series turn out to be divergent. Okay, and it's going to be the test that we gonna use here. So this thing is called the test for divergence. We use this test for divergence use only to conclude series n equal to 1 to infinity of an diverges. Okay, so we can use this test only for concluding that the series is diverges. So what does the series tell you is going to be if you have limit an does not exist, or if you have limit n go to infinity of an does not equal to 0, we can conclude that the series is divergent. And if you have the series is convergent, another series is divergent, the sum turn out to be divergent. Okay, this one is come from this proposition here. So if you have this guy convert, the limit must be 0. So if the limit not equal to 0, so this guy cannot convert. Cannot convert mean diverges. Okay, so it's going to be this guy not equal to 0 or doesn't exist. It means that this series cannot be convergent, so it is divergent. So that is called the test for divergence. Okay, so let's do example 18 first. When you have example 18, we like to show that the following series is divergent. So you try to see that this guy you have an, okay? So an equal to cos 2 over n. So you compute limit n go to infinity of an. So it's turned out to be limit n go to infinity of cos 2n. And you have this limit to be cos and n go to infinity, so this guy turned out to be 0, so it's going to be cosine of 0, and cosine of 0 equal to 1. Okay, so you have limit of an turned out to be equal to 1, not equal to 0. Let me move this one a little bit. Okay, so if you have this limit not equal to 0, so it's going to mean that the series n equal to 1 to infinity of cos 2 over n is divergent. Okay, by test for divergence. Here we have adjective. Okay, for conversion, divergent adjective is going to be ending with T, and the diversion here is going to be now. Okay, so it's a little bit different. So for, it must be followed by now. So it's going to be divergent with CE. Okay, that is a noun form for divert. And you're going to have the verb for this one is divert. Okay, so this guy is the verb guy. Last one, you have series n equal to 1 to infinity of e to the n plus 1 over n. And you can write this guy as series n equal to 1 to infinity of e to the negative n plus series n equal to 1 to infinity of 1 over n. And this guy turned out to be, okay, so this guy turned out to be 1 over e to the n, and you have r equal to 1 over e less than 1, so it is conversion. Okay, and for this one it is harmonic series. It is divergent. Okay, so you have convergent plus divergent, so the sum, okay, so you can conclude that the sum turned out to be e to the negative n plus 1 over n is divergent. Okay, so that is called the test for divergence. The next one, this one is about limit. Okay, so this one is going to be log minus log. So you can see that this guy, if you split into log n minus series log 2n minus 1, it's gonna turn out to be divergent, divergent. So divergent, divergent is inconclusive. Okay, divergent minus divergent is inconclusive. Okay, so you have divergent, divergent is inconclusive. So you not be able to do that. The thing that you be able to conclude turn out to be you need to just rewrite this an. Okay, so you have an given in terms of log n minus log 2n minus 1, and this guy will be log of n over 2n minus 1, okay? And you find limit n go to infinity of an, so it's going to be limit n go to infinity of log n over 2n minus 1. So this one will become limit n go to infinity of log, and you see that it's going to be n, it's going to be 2 minus 1 over n, okay, like this. So you see that it will be log of 1/2, okay, so it's going to be log of 1/2 because n and n get rid of this guy to infinity, to 0, and it's turned out to not equal to 0. Okay, so this guy not equal to 0. So when you have the limit of the red guy not equal to 0, so you're gonna conclude that, okay, so you're gonna conclude that the series n equal to 1 to infinity of log n minus log of 2n minus 1 is divergent. Okay, that's all. Okay, so I'm gonna go back to the previous example. Okay, so this one is example for the test for divergence. Okay, in example 17, you have an equal to 4n squared over n plus 1 over 2n minus 1. Determine whether the sequence an is convergent. So for number 1, you will need limit n go to infinity an. Okay, so it's going to be the limit of the red guy. Okay, so for this one, it's going to be limit n go to infinity of an equal to limit n go to infinity of 4n squared n plus 1 to n minus 1, and this guy will be 4n squared, and you have n 1 plus 1 over n 2 minus 1 over n, and this one you can just get rid of these two guys, and you're gonna have n go to infinity, this guy approach 0, 0. So this will give you 4 over 2 equal to 2, okay? So the conclusion will be, the first one is yes, it is convergent, and you have limit equal to 2, okay? So you have the limit of the red guy equal to 2. However, for B, you're gonna check the limit. So the limit turned out to be not equal to 0. Okay, so for B, you have limit not equal to 0 by test for divergence. We have from A that the limit n go to infinity of an does not equal to 0. So the series n equal to 1 to infinity of an must be divergent. Okay, so this is how we conclude for B. Okay, for B, it doesn't like compute Sn or anything. It's going to be just, you know, from A that the limit of An or limit of the red guy turned out to be not equal to 0, and you just use the test for divergence, that you're gonna be able to conclude that the series turned out to be divergent. Okay, so that's all for this lecture. It's going to be about the introduction for series that we have, and we're gonna do the test, the series test for the next lecture.